All right, slowly but surely we are getting through stoichiometry. This is the last piece of the puzzle that you need before we can do a full complicated stoichiometry problem. So lesson 6.07 is really getting into the idea of predicting how many moles of a reactant or product you need given how much you have of something. So the last piece you need is how to deal with molar ratios. So that's what we're going to define. And by the end of this, you'll be able to use that to calculate how many moles of any products or reactants you might need. Next lesson, we will then add the extra information about, dealing with if you have mass or volume or whatever. So, the molar ratio comes from your balanced equation. All right? So, the numbers in the balanced equation, all right, what does it mean if there's no number out front? Hopefully you're saying 1. All right, those coefficients tell you how many moles you need. Those coefficients can be turned into ratios. So, if you have 2 moles of hydrogen, you need 1 mole of oxygen. So there's the 2-to-1 ratio, which ratios can be written as fractions. And it's the fraction form that's going to help us when it comes to doing these calculations. All right, those fractions can also be flipped depending on what you need. All right. So this first one is probably a simple one you can do in your head, but I'm going to show you how to do the calculation so that you can see how it works and know that you're doing it right because you know what the right answer is supposed to be. All right, so you have 6 moles of hydrogen. How many moles of oxygen do you need? All right, so if it's a 2-to-1 ratio, pretty simple. 2-to-1, 2 times 3 gets you 6. So it would be a 6 moles of hydrogen, you need 3 moles of oxygen. Okay? So we know that's supposed to be our final answer. Here's how you set up the calculation, because you're not always going to have these wonderful, nice, easy to do in your head numbers. So the first step is take the value you are given in your problem and put it outside some parentheses. And I highly recommend writing your units and what chemical it is, because that's how you're going to keep track of this. All right, so this is going to go outside some parentheses that has a fraction in it. All right, this is the molar ratio. To appropriately set up your molar ratio, you're going to be using a math concept that I know you know. You might not be super familiar with it, but if I give you this, all right, 2x times 1 over x. Right now, that might look a little funky, and maybe you're not sure what to do. But this is the same thing as this. All right, I just separated out the x on the bottom into its own fraction inside some parentheses. And I'm sure you know what happens here. These x's cancel, and that leaves you with 2. All right? So, same thing here. The x's cancel. What we want to do is we need to cancel moles of H2 and switch to moles of oxygen. That is what the molar ratio does. Molar ratio switches which chemical you're dealing with. All right, so this is where you're going to switch from what you started in to the chemical that the question's asking you about. All right, in the bottom, you're going to cancel out what you started with. So we need to put moles of H2 in the bottom so that we can cancel that. we're going to put moles of oxygen up top because that's what we want to go to. The numbers, all right, that's where the coefficients come in. All right, so molar ratio comes from the balanced equation. All right, so if I go up to my balanced equation, hydrogen has a coefficient of 2, so I'm going to put 2 in the bottom. And oxygen has a coefficient of 1, so I'm going to put 1 on top. All right, and what this does, my moles hydrogen cancel. All right, just the moles, not the number. And then, math-wise, I have 6 times 1 divided by 2, which is equal to 3 moles of O2. All right, that ending unit is the one unit that's left that I haven't canceled out. So, we're going to do a bunch of examples here to make sure this sinks in. But if you need to, pause. Think about it a little bit. Rewind, watch again. All right, this is the key to doing stoichiometry correctly, is setting up these molar ratios. So, we have 12 moles of aluminum. How many moles of oxygen do you need? So our starting point is 12 moles of aluminum. That's what we put on the outside of the parentheses. All right. On the inside of the parentheses, all right, my molar ratio, I'm going to put moles of aluminum on the bottom because that's what I want to cancel out. Okay. On top, I'm going to put what I need to go to, moles of oxygen. And then where do I get the numbers for the molar ratio? Your balanced equation. All right, so aluminum is 4, oxygen is 3. All right, so moles of aluminum cancel out. I'm going to have 12 times 3 divided by 4, which is going to be 9. And the unit that I didn't get rid of is the unit of my final answer. So 9 moles of oxygen. All right, that's still probably one you might have been able to do in your head, but this next one, not so much. So, what goes on the outside of the parentheses? If you have 6.7 moles of oxygen, how many moles of aluminum oxide, Al2O3, will be made? All right, on the outside, you put what you start with, what you're given in the problem. All right, inside the parentheses, you're going to do your molar ratio. I'm going to put moles of oxygen on the bottom because that's what I need to cancel out. And then I'm going to put moles of aluminum oxide on top because that's what I need to answer. All right. Your molar ratio comes from your balanced equation. We know oxygen is 3. Aluminum oxide is 2. All right. So moles of oxygen cancel. And then I have 6.7 times 2 divided by 3, which equals 4.47 moles of aluminum oxide. All right. So, I am going to recommend that you pause the video here, try these two. I will do them, all right, but pause it and see if you can set everything up, do the right answers. Or try the first one, all right, and then pause again for the second one. But I've got 5.9 moles of FeCl3. How many moles of FeOH3 will be made? All right, so my starting point is the problem given, is the number given to me. So mole FeCl3. Set up my parentheses. In the bottom, I'm going to put moles of FeCl3 because that's what I need to cancel out. And I'm going to put moles FeOH3 on top. My numbers are going to come from my balanced equation. There's no number in front of FeCl3, so that means 1. And same thing for FeOH3. There's no number out front, so that's 1. All right, this one ends up being pretty easy calculation-wise. So I'm going to have moles FeCl3 cancel out. This is going to be 5.9 times 1 divided by 1, which happens to be 5.9 moles of FeOH3. Every once in a while you run into one where the molar ratio ends up being 1-to-1, and easy math. All right. Pause if you need to, again. But this next question, if you have 9.7 moles of NaOH, how many moles of FeOH3 will you make? This one will not be a 1-to-1 ratio. So I put 9.7 moles NaOH on the outside. Set up my parentheses. I'm going to have moles of NaOH on the bottom. Moles FeOH3 on top. Let's see, in front of NaOH, I have a 3. In front of FeOH3, there's nothing, so I'm going to put a 1. All right, that cancels those two. So I'm going to have 9.7 times 1 divided by 3, which is 3.23 moles of FeOH3. All right. So again, if this is not making sense, you need to talk to me, because this is the key to getting through a good chunk of the Unit 6 test. Another thing I want to discuss with you before moving on is the concept of a limiting reactant. So, what happens if, say, you have unlimited zinc, but, let's say you have 20 moles of zinc, but only 2 moles of hydrochloric acid. What's going to happen? What happens when that hydrochloric acid runs out? If you weren't thinking this needs to go into your brain. The reaction stops. All right? If you run out of one of the reactants, it's done. All right? You can't keep making the products unless you have the reactants. All right? So this comes into a few calculations that you will see, as you might be asked which reactant is limiting, all right, which means that's going to be the reactant that makes the least amount of product. Or another common thing related to this, you might see that you have 20 moles of zinc and excess HCl, all right? That automatically means zinc is your limiting reactant. Because if you have excess HCl, excess kind of sounds like extra, all right? It means you have so much HCl, you're never going to run out of it. Okay? So this just, sometimes what will end up happening is this determines where you are going to do your calculation for stoichiometry. So, just to give you a kind of definition here, all right, the reaction stops when one of the reactants gets used up. That reactant that is used up first, we call the limiting reactant, all right? It controls how much product you can possibly make. So, if you are asked to determine the limiting reactant given moles, you can use molar ratios to figure that out. All right, so you have 5 moles of zinc and 9 moles of hydrochloric acid. All right. Couple of different ways you can do this. I can calculate, if I can see, like, okay, so if I have 5 moles of zinc, how many moles of hydrochloric acid do I need to use all of that? All right, so that's one way I can do this. And this is going to, if this makes sense to you, this is going to be faster. All right, so option 1, if I have 5 moles of zinc, how many moles of HCl do I need? All right, to do that, you do 5 moles of zinc, set up your ratio. You have moles of zinc down here, moles of HCl up top, and then zinc is a 1, HCl is a 2, so 5 times 2 over 1, which equals 10 moles of HCl. All right, if I do it that way, do I have 10 moles of HCl? No. So that means HCl is going to run out first because I don't have enough. So HCl is limiting. All right. If I had enough, then zinc would be limiting. Okay? Or another way you can go about doing this, all right, option 2, is you can calculate how much of a product you're going to make. That would require 2 calculations. I'm going to do this up top so I have some room for the 10 moles of each. Option 2. All right, so for option 2, you're going to calculate how much product each reactant makes. So that's going to require 2 calculations. You're going to do 1 calculation with your 5 moles of zinc. And you're going to do 1 calculation with your 9 moles of HCl. All right. The key is make sure you calculate the same product for both. All right, so I can do moles of zinc to moles of H2. Okay, it doesn't matter which one you choose, just choose one of them. And then that's going to be, so my molar ratio for the other one is going to be moles of HCl to moles of H2. All right, make sure you calculate to the same product. So if I plug in my molar ratio numbers, zinc is a 1, H2 is a 1, and HCl is a 2. So I'm going to have 5 times 1 over 1, which equals 5 moles H2. And here I'm going to have 9 times 1 divided by 2, which equals 4.5 moles H2. Whichever one is the smaller number is your limiting reactant. So again, HCl is limiting. All right? Because that HCl can only make 4.5 moles of H2, which means we'll never get to the 5 that the zinc could provide because the HCl will run out first. All right? So if you have 10 moles of each, again, I'll show you both options. Option 1, all right, I'm going to do 10 moles of zinc, moles of zinc, moles of HCl. It's going to be a 1 and a 2, which means I need 5, oops, nope, I'm doing my math wrong. Let me write that out, which is going to be 10 times 2 divided by 1, which means 20 moles of HCl. I only have 10 moles, so that's not possible. All right, so HCl is limiting. Option 2, I do 2 calculations. All right, I do my 10 moles of zinc, and I do my 10 moles HCl, and I do both of those to the same product. All right, so moles of zinc, let's go to H2 again. Or you know what, just to do something different, moles ZnCl2, just to prove that this works regardless of what one you use. Coefficients there are both 1s, so that's going to be 10 moles ZnCl2. Then my 10 moles of HCl, alright, some moles of HCl on the bottom, moles of ZnCl2 on the top. That's a 2 and a 1. That's only going to make 5 moles of ZnCl2. Alright, so the smaller number is the only one that's actually possible. So again, HCl is limiting. This is something that is covered in the test. You're only going to see a couple of questions. But because of that, if this doesn't make sense, let me know.